times 5. And its moment is a negative or positive? Negative or positive? So our rule, counterclockwise is a positive, clockwise is a negative. So it will be negative, and from your calculations, we can calculate M finally like 5,077.64 pound per feet times feet. The moment is a torque is unit of force times unit of distance. Good. Let's ask you questions. If I didn't, for example, if I have a problem like that, and I didn't tell you the A is an internal point, and dx and dy is an internal force. And dx, dy, m is unknown, or unknown. And I want to calculate it is unknown. How to start? Start summation force or summation moment. We have a 3 unknown. Ex, ey, m. If we took force in x and y direction, we have to unknown ex and dy. So we need another equation to solve the unknowns. But if we start with summation moments, you will delete it ex and dy, and you find your unknown. Your only unknown is m, and start to calculate m, and after that apply summation force in x and summation force in y to calculate ex and dy. So think about that. If you have 3 unknowns, like 2 forces and moments, take moments about the point which the 2 forces acting to delete them, because the moments is equal to 0. And you find you have just m as unknown. And after that, you can apply whatever you want to calculate the other forces. But first, don't start with a point having me unknown. I think my time is run out, but let's make a conclusion for our lecture. First, when you study or you want to calculate forces acting on a rigid body moving with velocity v and acceleration e, first, draw free body diagram. What is the free body diagram? It's easy. Draw your body, show the external forces and the moments with their angles. Good? Second, draw kinetic diagram. Kinetic diagram, it is the same body but showing acceleration. So body have forces and the other diagram have acceleration. And once you have a 2 diagram, apply the equations. Summation force, for example, in x direction, m egx. Egx means that's the x component of the gravity of the acceleration at g. Summation force in y direction, for example, maybe you will study in x and z or y and z or t and n. M AGY. Good? If you have a rotation for the body, so the summation in moment about G, center of gravity of the body, is equal second moment of inertia around G. Keep this in your mind, times what? Alpha, which is the angular acceleration. You cannot apply this equation in any point except the center of gravity. But if you want to apply the summation of moment about any other point, it's easy. Summation of moment of all forces which in the free body diagram around point B equals summation moment, which is called the kinetic moment around B. Kinetic moment around B is easy, is equal IG alpha, which in equation number 3, plus the moment of MAG. It's easy. Good? And this keep your mind IG alpha at center of gravity G. Good? And if you want to calculate I in other points, we can make some square of second mode as you teach. Again, in any problem, we have two types of forces. External forces, which acting in the out surface of the body. We have internal forces, which if you want to study the internal reaction inside your system to check if it's safe or not as a design. Yeah, for the internal forces, if you have a fixed point, something doesn't move, doesn't rotate, so we have Ax, Ay, M. If you have a rotation, so we have only Ax and Y. However, if you have a sliding in X direction, so there is no force in X direction, but we have a reaction or internal force in Y direction. Good? Second, if you have a friction force, it's equal some kind of coefficient called the friction coefficient, dynamic of course, times N. N means what? The normal reaction. So if you have a body like that and moving in this direction, so this is your weight and this is your normal reaction and this will be your friction force, which is equal mu times N. Good? And keep in your mind the coefficient of friction can be different, static or dynamic. Dynamic, which means that the body is moving. Static means that the body is starting to move, but it is still not moving. Good? Thank you. You're welcome.